Page 7 of HL Functions Addendum. Um, Here we're going to use the calculator to graph more complex functions and find their intersections. Make sure you know how to do that. For example, in this case, we have this function, which I don't expect you to be able to graph by hand, and then this function, which I do expect you to be able to graph by hand, right? This is just a quadratic, inverted and translated up 11, okay? But this is not expected. Okay, so let's put both of these in the calculator. We are going to put first in y1, we'll put the x squared minus 4x. So we'll put x squared minus 4 divided by x. If you want to, you could use a vertical fraction, but in this case not really necessary because there's only one symbol in each. Okay, so that is the first one. And the second one is negative x squared plus 11. Make sure you put this negative and not the minus because it's a leading minus sign. X squared plus 11. Now we're going to graph these two. Oh, so that's this weird one. Okay, I don't expect you to know how to do that. And here is the inverted parabola. And so if we wanted to graph this on here, let's see. First of all, the interesting part of it is where there's the intersection. So it would be kind of like the positive area. So I don't know how high we need to go. Looks like we need to go maybe like 15 units or so. So let me redo the window so that the sides are negative 5 and 5, and the y min would be 0 because we don't really care about the bottom part. And then we'll put about 15 here. Let's see what that looks like. Okay, so that's most of the interesting parts. So if we were going to graph this, I would say, okay, this is the red function. This is the blue function. So I'm going to graph the red function kind of like this. And like that. And then I'm going to graph the blue function as inverted parabola, like that. And of course I would do this more precisely on the exam. The way you could get individual points to graph on the exam would be if you did second table. And you see how second table gives you exact points for both the red function and the blue function. Okay, so that's how you would do that. But I just sketched it here so that we'd have something to work with. One of the solutions to f of x equals g of x, so red function equals blue function, is x equals 2.51. Guess which one that is? Well, that means a solution to this equals this is an intersection. Here's an intersection, here's an intersection, here's an intersection. X equals 2.5 is which intersection? It would have to be this intersection because x equals 2.5 is positive. So this intersection point is to the right of the y-axis. Okay, so that would have to be that one, right? This is 2.51. Use technology to determine the other two negative solutions. So this is easy. We're just going to do second calc 0, or second calc intersect. And then we'll say, is the first curve x squared minus 4 divided by x? Yes. Is the second curve? Yes. Oh, you know, what happens sometimes weirdly is like the cursor starts at x equals 0. And in this function here, there's an asymptote at x equals 0. So it makes the calculator freak out. So to actually make the thing select this function, you have to go a little bit to the left or the right. And then you can say, oh yeah, the first curve is this, and then it'll accept it. Second curve is negative x squared plus 11. Yes. And then where's your guess? Well, let's go to the leftmost one first. So we move the cursor close to the leftmost one. We hit enter, and it tells us the intersection is negative 2.14. So this first point here has an intersection of x equals negative 2.14. It didn't ask us for the y, so we won't write down the y. Second calc, now we're going for the other one. 6, 5 is the intersect. First curve, yes. Second curve, yes. And now we're going to move the guess toward the second point, which is here. The second intersection is negative 0.373. Okay, so this one here is negative 0.373. Okay, and this one we already knew, it's 2.51. All right, that was easy, right? Now we're going to sketch two other functions, which is this, which I don't really expect you to know how to graph, and this, which is just a simple parabola. Okay, so let's do that. So first we're going to put the square root, and then underneath the square root we're going to put x squared minus 2x plus 9. X squared, x squared plus minus 2x minus 2x plus 9. Press the right arrow to get out of the square root sign. And then the other one would be just a plain old x squared. X squared. Now graph these two. And this is the x squared, and this is the weird square root of a square thing, okay? And then we're going to solve this function, which is like, let's do this again. We'll do blue function equals red function. Okay, so when are those two equal? We're supposed to sketch the graph. So the blue function is this weird thing here. We'll kind of draw that. And the red function is the regular parabola. It looks kind of like that. So there's this intersection and there's the intersection. If you want to graph it precisely, then, as I said before, you go to the second table and you get a few points. Why don't we do that, just so that you can see how you would do that on the test. So the blue function is the first one, so we'll do the blue function first. And we'll get a few points, like 0, 3, 0, 3, and 2, 3, 2, 3, and there are no other nice numbers here. Let's grab like 10, 9.4, 10, 9.4. Okay, and let's go to the left. Negative 10, 11.35. Okay, kind of like that. All right, so that's the blue function. The red function would be this one here. So 0, 0 is one of the points. Actually, these are very familiar points for you because this is a regular parabola. 1, 4, 9, 16. Now this is kind of the uninteresting part because we're only worried about when it intersects, right? So, okay, so it kind of looks like that, right? So the intersections are here and here. Let's find those intersections using second calc intersect. So first curve is this square root function, yes. Second curve is the x squared function, yes. And our first guess, we're going to move closer to that one, and we'll hit enter, and the intersection is negative 2.04. Okay, and then we're going to find the other intersection using the exact same procedure, second calc intersect. First curve, yes. Second curve, yes. And then we're going to move the cursor closer to the second intersection. And then we hit enter, and then it gives me 1.71. Okay? So, that's it. All right. Let's do page 8 problem together with this. Part of the graph of y equals f of x is shown alongside. Copy the graph and on the same set of axes draw the graph g of x equals negative 1. Okay, so g of x equals negative 1 is a horizontal line. It is about there. Okay, I'm going to draw it for the domain negative 5 to 4. Hence, state the number of solutions of f of x equals g of x on the domain negative 5 to 4. There's only one solution. It's right there. So it's one solution. C, consider the function h of x equals k on the domain -5 is less than or equal to x is less than or equal to 4. For what values of k does f of x equal h of x have? Okay. Okay, so basically what they want to do is they want you to think about a horizontal line at height k that you're going to draw at any point on this graph. So like there's this one, there's this blue one here, there's this brown one right there, and there's the red one, which I already kind of drew. So let's think about the blue one. The blue one is kind of like, okay, anywhere from here to here. But basically what makes the blue one is it only intersects the function once, right? And the brown one only intersects it twice, and the red one intersects it once, okay? So, is there, oh, look at that. No, the brown one actually hits it 3 times, doesn't it? And now I thought of like 2 other conditions, which would be, let's say, the black one. The black one would hit it twice right there, right? And the x-axis also hits it just twice, okay? So for what values of k does the intersection have 3 solutions? That would be 3 solutions would be only the black line and the x-axis. So the 2 solutions would be k equals 0, which would be the x-axis, and k equals 1, which would be the black line. Okay, and you know what I'm going to do? I'm going to write it in black so that you can see that what I'm talking about. So the 3 solutions would be when k is equal to 0 and when k is equal to 1. Do you see the 1 there? There would be 1 solution when you have the blue or the red line. So the red line would be k is anything less than 0, and the blue one would be k is greater than 1. Okay. And then when would you have 2 solutions? I'm sorry. Didn't mean to confuse you there. This is the answer for 2 solutions, right? Exactly, 2 solutions. The answer for 3 solutions is the brown line. So the brown line would be cutting it 3 times, right? 1, 2, 3. That would happen when the brown line is between 0 and 1. So k between 0 and 1, which is the brown line, is 3 solutions. And no solutions would be anything that's pink, which would be above here or below here, which would be k is greater than 8, or k is less than -3. Okay? So that's it for number 3.